Welcome, everyone, to Artificial Intelligence Unorthodox Lessons. Great to have you with us.
Hello.
Today, we're doing another deep dive, this time exploring something I think is really fascinating. It's the relationship between, well, what people call traditional AI and the newer generative AI stuff.
Yeah, it's a hot topic. Easy to see them as totally separate worlds, isn't it?
Totally. But we've been looking at some discussions, some sources, and the idea is maybe they're not so separate, that the core AI principles actually connect them.
Exactly. That's the angle.
And before we jump in, a big thank you to our sponsor, Notion Wave. They're a leading AI company doing great work in research, education, and, well, loads more. Check them out.
Definitely worth a look.
So our mission today really is to try and give you, our listeners, a clearer picture of how these fundamental AI ideas, pop up in both traditional and generative models. Hopefully it helps everyone navigate this whole AI landscape a bit better.
It's such a needed perspective, I think. All the hype around generative AI can make it feel like it just, appeared out of nowhere.
Right, like it's completely new.
But when you dig into it, you see how much it builds on, well, decades of AI research. These foundational concepts, they're still there, just evolving, taking established ideas in really surprising directions sometimes.
Okay, so the framing shouldn't be traditional versus generative. More like they work together.
Precisely. Think of it as a bigger AI toolbox. They're different tools, maybe for different tasks, or maybe even used together.
Ah, okay. So it's not about picking a side.
Not at all. The smart approach really is understanding the strengths of each. When do you need the predictability of traditional methods? When do you want the creativity or flexibility of generative? Knowing that lets you blend them.
Blend them. Interesting. That could lead to some really innovative solutions, I bet.
That's the idea. Get the best of both worlds.
All right, let's dig into some of these core concepts then. One thing that jumped out from the sources was this contrast. Reproducibility versus self-consistency.
Big difference there.
With traditional AI, the goal is usually like exact same input, exact same output every single time. Super important for some applications.
Yeah, absolutely critical. Think medical diagnostics or maybe financial predictions. You need reliability. Consistency is key.
Okay. But then generative AI introduces self-consistency. What does that actually mean in practice? It sounds a bit looser.
It is, in a way. The output might not be identical each time you run the same prompt, but the key thing is logical coherence. Does it make sense within itself? Does it stay relevant to what you asked? That's the focus.
So less about perfect clones, more about making sense internally.
Exactly. It's about maintaining a consistent line of reasoning or style within that specific generated output.
So for our listeners thinking about this, when would you prioritize one over the other? Reproducibility versus this self-consistency thing?
Well, like we said, if you need absolute, verifiable, repeatable results, maybe for safety-critical systems, traditional AI's reproducibility is probably what you want.
No room for error.
But if you're brainstorming, generating creative text, exploring different options, that's where self-consistency shines. You get variety, but it's, useful variety. It stays on topic.
You could even imagine feeding a reliable traditional output into a generative model for creative variations, couldn't you?
Now you're thinking, yeah, combining them. Get the reliable core, then riff on it creatively. That's blending the approaches.
Cool. Okay, another pair. Feature extraction versus reasoning models. This sounds like it gets at how they handle data differently.
It really does. This is a fundamental shift. With traditional machine learning, a huge amount of work often goes into feature engineering.
Which means?
It means humans, data scientists, have to figure out beforehand what parts of the data are important. What are the key features the model should pay attention to? You manually extract or design these.
Right, like telling the model, look at these specific columns or calculate this specific ratio.
Exactly. It requires a lot of domain knowledge and effort up front. Generative AI, especially the big models like GPT-4 or Claude, they're different. They can often take in much more raw, unstructured data, text, images, whatever.
And they figure out the features themselves?
Kind of. They rely on their complex internal reasoning capabilities built from training on massive data sets. They learn the patterns, the relationships, the important bits without needing us to explicitly point them out. It's more end-to-end.
That's a huge difference. Shifts the workload from manual feature crafting to, well, what?
To things like data quality, model architecture, and importantly, how you interact with the model. Which leads us nicely to the next point, actually.
Right, okay. Hyperparameter tuning versus prompt engineering. Both sound like ways to tweak performance.
They are, but the how is different. In traditional AI, you're often fiddling with hyperparameters. These are like settings on the model itself, learning rate, number of layers, things like that.
And you adjust them through trial and error, lots of experiments.
Yep. It's an iterative process. Run, check results, tweak, run again. With generative AI, especially large language models, the main lever we pull is the prompt.
The instruction you give it.
Precisely. Prompt engineering, crafting really effective prompts, is how you guide the model and optimize its output. It's less about tuning the engine's internal knobs and more about giving it clear, smart directions.
So it's like becoming a really good communicator with the AI.
You got it. That skill, prompt engineering, is becoming incredibly valuable. It's a new kind of expertise.
Makes sense. Okay, next up, model ensembling versus multi-agent systems. Ensembling sounds familiar from traditional ML.
Yeah, standard practice. You train several different models, maybe using different algorithms or data subsets, and then you combine their predictions.
Like getting a second, third, fourth opinion. Usually improves accuracy, right?
Generally, yes. It makes the overall system more robust. Now, in the generative space, we're seeing this idea of multi-agent systems emerge.
Okay, what's that about? Sounds like more than just combining predictions.
It is. Think of multiple specialized AI agents, maybe each good at a different task, actually interacting with each other, collaborating to solve a complex problem.
Whoa! So they talk to each other.
Effectively, yes. They might pass information back and forth, delegate tasks. It's a much more dynamic, distributed way of working compared to just averaging votes like in a simple ensemble. Still early days for a lot of this, but very exciting.
It sounds potentially way more powerful
Yep.
and complex. Okay, let's talk improvement. Traditional AI has boosting. How does that work? Quickly.
Boosting is sequential. You train a model, see where it makes mistakes, then train the next model to focus specifically on fixing those mistakes. Each new model builds on the last one, paying more attention to the hard examples.
Got it. So what's the parallel in generative AI?
The sources pointed towards things like iterative improvement or self-refinement. It's kind of fascinating.
The AI improves itself.
In a way, think about techniques like chain of thought prompting. You ask the model not just for the answer, but to show it's working, it's step-by-step reasoning.
Ah, okay, I've seen that.
That process itself can lead to better answers. Or self-critique prompts, where you literally ask the model to review its own first draft and suggest improvements. It's like the AI is iterating on its own work, similar to how boosting focuses on errors.
That's pretty meta. The AI learning from its own thought process. Powerful stuff. Okay, two more pairs. Regularization versus temperature control. Regularization in traditional AI is about.
Preventing overfitting, mostly.
Yeah.
Overfitting is when your model learns the training data too well, including all the noise and quirks.
So it performs great on data it's seen, but badly on new, unseen data.
Exactly. Regularization techniques add constraints or penalties during training to discourage the model from becoming overly complex and just memorizing the training set. It helps it generalize better.
Makes sense. So temperature control in generative AI, is that doing the same thing? Preventing memorization?
Not directly in the same way. Temperature is more about controlling the randomness, or you could say the creativity of the output during generation. A low temperature setting makes the model stick to the most likely, most predictable next word or token. The output becomes more focused, more deterministic.
Stop drawing, maybe.
Sometimes. A higher temperature introduces more randomness. The model is more likely to pick less common words, to go off on tangents. It leads to more surprising, novel, creative results, but potentially less coherent ones, too.
Ah, so it's a dial between predictable and creative, not strictly about overfitting.
Exactly. It's about tuning the output style.
Interesting. Okay, cross-validation versus prompt sensitivity analysis. Cross-validation. That's for checking if a traditional model works on new data, right?
Yeah, it's a standard technique. You split your data, train on some parts, test on others, rotate the splits. It gives you a more reliable estimate of how well the model will perform in the real world on data it hasn't seen during training. It assesses generalization.
So how do you check that kind of robustness for a generative model where the input isn't neat data splits, but prompts?
The analogous idea is something like prompt sensitivity analysis. You don't have neat validation sets in the same way. Instead, you test how much the model's output changes when you make small tweaks to the prompt.
Like asking the same question in slightly different ways.
Exactly. Phrasing it differently, adding a detail, removing one. If small changes lead to wildly different or nonsensical outputs, the model might not be very robust or reliable for that type of task. You're probing its understanding and stability.
So stress testing its comprehension through variations in the instructions. Makes sense.
Mm,
And the last one, explainability versus chain of thought reasoning. Getting inside the black box.
Always a challenge in AI. With traditional models, especially complex ones, understanding why they made a certain prediction often requires using separate post-hoc explainability tools, things like SHAP or LIME that try to approximate the model's reasoning after the fact.
Okay, so it's an extra step trying to figure it out afterward.
Often,
Yeah.
yes, but with generative models, particularly using techniques like chain of thought,
Which we mentioned earlier.
right, where you ask it to explain its steps, you get a form of inherent transparency. The model itself generates the explanation as part of the output.
So the explanation is the output or part of it.
Exactly. It's not a perfect window into its soul, but seeing that step-by-step derivation of an answer gives you real insight into its process. It can be that aha moment.
Yeah, seeing the logic unfold definitely builds more trust than just getting an answer spat out.
Absolutely.
So putting this all together, it really does seem like generative AI isn't some alien technology. It's deeply rooted in these established AI ideas, just manifested differently.
That's the core message, I think. It's an evolution building on the foundations. And the real takeaway for listeners, hopefully, is that understanding these foundations, reproducibility, feature handling, optimization, ensembling, generalization, explainability, helps you make sense of both worlds.
Right. It lets you see the connections and appreciate what generative AI is actually doing, rather than just seeing it as magic.
And critically, it helps you become a better practitioner. Knowing these principles allows you to choose the right tool, or even combine tools, more effectively. The most skilled people will be the ones who understand the whole spectrum.
It's about that bigger picture, isn't it? Not just chasing the latest shiny object, but understanding the fundamentals that drive progress across the board.
Precisely. At the end of the day, all AI, traditional, generative, whatever comes next, is fundamentally about solving problems. The broader your understanding of the techniques, the better the solutions you can build.
Well said. Okay, so let's quickly recap the main points for everyone listening.
Good idea.
First, try not to think of traditional and generative AI as enemies. They're complementary tools in the same box.
Yeah, different strengths for different needs.
Second, those core AI concepts we talked about, reproducibility, features, tuning, ensembles, validation, explainability, they don't disappear with generative AI. They show up in new forms like self-consistency, prompt engineering, multi-agent systems, and chain of thought.
Understanding those connections is key.
Third, getting a grip on these underlying principles is really crucial for actually using AI effectively, whichever type you're dealing with.
It empowers you to make better choices.
And finally, mastering both sets of tools, knowing when to use a traditional approach, when to use a generative one, or even how to combine them, that really expands your problem-solving power.
Absolutely. It makes you a more versatile and effective AI practitioner or user.
Perfect summary. So maybe a final thought to leave people with.
Okay, how about this? Think about a specific challenge or problem you're dealing with right now, maybe at work, maybe a personal project, and just spend a few minutes considering how could a traditional AI approach help? What would that look like? And then how could a generative AI approach offer a different angle, a different kind of solution? Could you even combine them?
So applying this thinking directly.
Yeah, just pondering that connection for a real-world problem might spark some really interesting ideas. It makes it concrete.
Love that. Definitely food for thought. Well, thanks so much for joining us on this deep dive.
My pleasure.
And for everyone listening, if you found this useful, please do follow Artificial Intelligence, Unorthodox Lessons. We've got plenty more explorations into the world of AI coming up.